Hey guys, it is now the 19th, and I know you're sitting there saying, wow, 3 days have come and gone, and Mrs. Obdig's wearing the same shirt. Things are not that bad yet, okay? I understand that I cannot go to TJ Maxx and shop. There's always online. I'm just in school one day trying to film as many lessons as I can. I'm learning a lot about my phone and about YouTube. So, as you're learning, I'm learning. Okay, so we're going to do another lesson with trigonometric equations. Trigonometric. I think I said that wrong. Equations. This one you're definitely going to want to have your formula sheet and your identity sheet that I had given to you prior to us leaving school. I want to say going on break, but this is definitely not a break. I'm going to try and upload this to Teams, but you should all have it on you, okay, because you're going to be using that. So hopefully you'll be doing okay with solving these equations. I want to show you something else. So here's 2 cosine squared theta minus sine theta equals 1. Okay, so hopefully by now you recognize second degree. We're going to set it equal to 0 and try to solve it. However, guys, we are not going to be able to factor this having a cosine and a sine. How do I make factors with that? Okay, it's not going to work. Hopefully you see cosine squared theta, and bells should be going off in your head. Ding, 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 ding. That is one of the Pythagorean identities. And if things were like it was supposed to be, we're going to have a little quiz on that. But we know in the Pythagorean identities that, don't worry, I just got a little phlegm, that sine squared x plus cosine squared x equals 1. And I can solve for cosine squared x by bringing sine to the other side. So cosine squared x is equal to 1 minus sine squared x. So what I can do is I could replace cosine squared x with 1 minus sine squared x. Or in this case, theta. Okay, I'll let you absorb that for a second. Okay, so as you can see, I just replaced that, and now look, everything is going to be in terms of sine. Now I'm just going to do algebra. I'm going to distribute the 2. I'm going to combine like terms. I have a 2 here and a minus 1 there, so I'm going to have negative 2 sine squared theta minus sine theta. 2 minus 1 is 1. Now, I don't know about you, but I don't like factoring anything that has a negative leading coefficient. So I'm going to multiply everything by negative 1. So I'm left with 2 sine squared theta plus sine theta minus 1 equals 0. Now I'm going to factor this. Again, I'm going to do it off on the side because it involves my trick. So 2x squared plus x minus 1. Take the 2, multiply it by the 1. X minus, no, plus 2. X minus 1. Bring the 2 back in, so it's going to be x plus 1. 2x minus 1. Did I get on film? Okay, good. So now it's going to be sine theta plus 1 times 2 sine theta minus 1 equals 0. Again, setting both of them equal to 0 and solving. So I get sine of theta is equal to negative 1. Who has a sine of negative 1? It's 3 pi over 2. And then this is going to work out to be sine theta equals 1/2. So theta will be pi over 6 and 5 pi over 6. And again, you should have your unit circle handy with you, or you should have your little index card. Okay, I'm going to pause this while I put another problem on the board. Okay, I have 2 parentheses sine theta plus cosecant theta. All right, again, I have 2 different functions. There's no way I'm going to be able to factor that. So I'm going to distribute the 2 first. Now, some of you might have wanted to switch cosecant to 1 over sine from the get-go. That's fine. I'm going to do it this way. And at the same time, I'm going to bring the 5 over because you know you're going to have to set it equal to 0. All right, I'll rewrite it in terms of sine. Okay, who likes to factor with fractions? No? All right, I'm sitting in front of an empty classroom. No one raised their hand. So let's get rid of the sine. How do we do that? We multiply the whole thing by sine theta. So now I get 2 sine squared theta plus this will cancel out. And I'll just be left with 2 minus, when I distribute this, 5 sine theta equals 0. All right, now I'm going to factor it. First, I'm going to write it into descending order, standard form, if you will. You guys all doing out there? Miss me yet? Okay, again, I am factoring something with a leading coefficient of 2. I'm going to do my trick over on the side. So 2x squared minus 5x plus 2. Take the 2 up. Yes, multiply it over there. X squared minus 5x plus 4. It's going to be x minus 4. X minus 1. Bring the 2 back into the equation. I've done this trick enough times that you should know it by now. If not, I do not know what to tell you. Okay, so now I have to put the sign back in. So sine theta minus 2. That doesn't look good, does it? And 2 sine theta minus 1 equals 0. Okay, set them both equal to 0. This is going to equal 2, which we know we're going to reject. It's an empty set, does not exist. It's got to be less than 1. And over here I have 2 sine theta equals 1. Sine theta equals 1/2. So theta is going to be pi over 6 and 5 pi over 6. And that's going to be your answer. Okay, so these are a little more challenging. I think you have 3 or 4 of them for homework. Okay, you're going to be using your formula sheet a lot. You're going to be looking at reciprocal identities, but more importantly, you're going to be looking at the Pythagorean identities. Not just the 3 that are on the sheet. Remember, we have 3 on the sheet, but technically there are 9, the way you can move them all around. So make sure you keep that in mind when you try to do your homework. So basically, this is going to be the last lesson of 5-3. I'm probably going to do a little review with you tomorrow, and then we're going to take a mini quiz before we move on to the second part. The identities that we had in the beginning, okay, the verifying, I cut that short. I'd rather see you face to face to do that. So we're just going to do a little of that. So tomorrow I'll have a review for you. Bye, guys.